If you're looking to collect your logs, metrics, traces, transform the data, and send it to the Observability backend of your choice, then this episode is for you. Welcome to Is It Observable? Today's episode is part of the Kubernetes and OpenTelemetry series, where we in fact have covered a couple of episodes. How to collect logs using Loki and Fluentd and Fluentbit and many others. What is Kubernetes? What is SCADA? How to auto-scale your Kubernetes cluster? What is the Captain Lifecycle Toolkit? Today's episode will be focused on a CNCF project that we in fact have already presented in this channel. This project was initially built to collect and process your logs. And I'm referring to Fluentbit. Since KubeCon Detroit, Fluentbit v2 is not limited to logs anymore, but can collect metrics and traces. That sounds so exciting, so let's have a look at the latest updates of Fluentbit. If you enjoyed today's content, don't forget to like and subscribe to the channel. So let's see what you are going to learn out of this episode. We will start with an introduction reminding what is Fluentbit. We will then look at the news related to the Fluentbit version 2. We will briefly introduce the stream processing capabilities of Fluentbit. We will run a short comparison with the OpenTelemetry Collector. We'll have an interview with the founder and maintainer of the Fluentbit project, and I'm referring to Eduardo Silva. In the episode explaining how to configure Fluentbit to collect your logs from your Kubernetes cluster, we already have presented most of the features of Fluentbit related to logs. At that time, Fluentbit was only supporting logs. Metrics and traces was actually not part of the scope of the Fluentbit project. Fluentbit is now the most popular log agent collector of the market. His big brother Fluentd is also very popular, but designed for bare metal technology and also to process very complex tasks. A Fluentbit agent will collect and parse our logs based on a pipeline that we need to create again. At the end of the day, the pipeline is the configuration file of Fluentbit. It means that the Fluentbit agent starts, loads the pipeline that we have defined. The pipeline will probably collect data with the help of input plugins, parse the content with the help of a parsing plugin, filter the data. Filtering means modifying the structure or deleting assets from the data of our content. Last, we export the data with the usage of output plugins. Fluentbit can be deployed in various ways in Windows, Linux, Mac, Docker, and of course, Kubernetes. In the case of Kubernetes, you can deploy in a traditional way using a daemon set and a config map that will hold your pipeline. Otherwise, the Fluent community has built an operator helping us to deploy and manage the updates of our pipelines. When using the operator, the design logic of Fluentbit pipeline is slightly different from a traditional Fluentbit pipeline. If you want to learn more about the operator, check the video related to the operator. Fluentbit is so mainstream that most of our cloud providers are relying on Fluentbit to collect logs from a cluster and forward them to the log viewer or log storage solutions of the cloud provider. Fluentbit manages our data respecting a specific format. So here is the format. So you can see that it's like a JSON payload with the log contains the message of the logs. The stream could be std out, stdr, and then we have a label objects with the various labels related to our logs. It means that we can easily access our data using record accessors. So $logs will reach out to the log property. $labels, with the name of the labels, will reach out to the right label of your choice. The power of Fluentbit pipeline is the usage of tag. Each input source can be tagged. The purpose of tag is to route our logs to the right parser filter, or output plugin using the match parameter. For example, if I want to collect logs for my Kubernetes cluster, so I will first use the input plugin tail that will basically read from files. As you can see here in this example, we have a specific path called var log containers. Just to remind, every Kubernetes node, there will be an agent of Fluentbit that is able to read the files from the node. And all the containers that starts in the Kubernetes are stored in the same path in our nodes. So var log containers, and then we'll have the container ID and so on and so forth. So with this path, we are able to read all the logs from a Kubernetes cluster. And here, as you can see, we are tagging that input with kube.star. So then, if I want to apply a filter, for example, the Kubernetes filter that will add extra metadata in the top of our logs, then here I'll use the match kube.star to say I want to apply that filter to only the source having that specific tag. That is a way of building a complex pipeline where we can apply a specific parser or filter to a specific type of data. What about the other signals? So to extend the observability supports of Fluentbit, the community has worked on the support of other signals, metrics, and traces. In fact, if we just look at the nature of the standard format of observability, yes, I'm referring to OpenTelemetry. OpenTelemetry is providing a standard structure for our various signals, starting from, of course, traces. We now have the support of metrics, and now we have also the log supports. It means that we have now a standard schema to structure our telemetry data. And this standard, at the end of the day, is a JSON payload having several properties like resources, label, attributes, and so on. So there's one thing that Fluentbit is really good at, is parsing text and JSON data. Which means Fluentbit community was very smart to utilize the power of Fluentbit to receive, parse the telemetry data, exchange in a JSON or text format. Out of the support of metrics and traces, the Fluent community has worked on major improvements on the Fluentbit agents. So first, there is a new way of designing our pipeline. It's the YAML configuration file. In a traditional way, designing a pipeline in Fluentbit uses a specific format, a schema, where each section of our pipeline's input, filter, and so on are structured the following way. So here we have first the type of action, so input, filter, output. So in our case, it's input. Then we add the name, which is the name of the plugin that we want to utilize. And then we have various settings of the input. Last, as mentioned, we can add a tag if you want to apply a tag to the source that we want to collect here in this example. Fluentbit is introducing now a new way of defining our pipeline. Currently, it's only available in preview mode. Our pipeline will be structured using a YAML structure, where there are three sections. So first, we have the first section, which is environment, so env, where we can define variables. Then we have services, so configuring the global property of the agent, similar to the service object that we have used in the past. And last, we have the pipelm object that will hold three main sections of our pipeline. So inputs, where we define all our input plugins, filters, where we will add all our filter plugins, and of course, output, where we add all our output plugins. For example, here we have a service definitions. So we define a log level to debug, and then we have a pipeline using the input CPU and the output stdout. Back pressure. This is not a new feature, but it makes sense to remind that Fluentbit has a back pressure feature. Processing and filtering a large number of data can end up generating high memory consumptions on the agents. To control the memory usage, on the agents and avoid out-of-memory situations or back pressure, we can define in our input plugins the parameter names mem_buff_limits, so memory buffer limits. This settings is crucial. If you are collecting data, you will probably going to send it to an output source. If the output source is rejecting our data or is not responding in time, so the data as a consequence will be kept in memory until we retry to send the data. And in fact, in parallel, we may also collect extra data, and that at the end will increase the data stored in the memory of the agent. The memory limit is there to pause the input plugin until the data has been pushed. That is the reason why each plugin has a pause and resume settings that will be used as a callback in this specific memory pressure situation. The Fluentbit monitoring. What is fantastic and not new is the fact that Fluentbit is exposing by default metrics on the port 2020 of the agent. The metrics produced will be accessible in various HTTP endpoints. So we have the API v1 uptime producing the JSON objects with the uptime information. We have the API v1/metrics producing a JSON format with internal metrics on the various plugins used in our pipelines. We have API v1 metrics/Prometheus. It's a similar metrics but in a Prometheus format. We have the API v1/health to report the health checks results. The metrics produced in a Prometheus format are currently described in the Fluentbit documentations. So here is the link to the documentations related to the Prometheus metrics. Expect. Expect is a new filter plugin, or at least I just discovered it and I think it's just fantastic. It helps us to validate that the data is structured as expected. We can now run expect after each plugin that will modify the structure of the data. For example, I use tail to collect some data from files, then I use grep, then I can use a filter plugin like record modifier to change the structure of the data, and then I send it to the output plugin. I may want to add in that pipeline a couple of validations between each steps. So we can do tail, then we use expect to control that the logs is structured in the right way. And then we use grep, so we can also then after the grep add an expect filter plugin to control that our data is also structured in the right way, and then we can do it on each of those steps. So expect is a wonderful way of making sure that our data is being properly processed before moving to the next steps of our pipeline. The new input plugins. So let's have a look at the new input plugins. By adding metrics and traces, we expect to have new input plugins and also new output plugins. One important note. As of now, metrics and traces collected are running through a separate pipelines from logs. And you won't go through the filter plugins currently. So we'll have to be patient to utilize those filter plugins in our metrics and on traces. So let's have a look first at the input plugins collecting metrics. So we have the Fluentbit metrics. It's an input plugin that will expose the Fluentbit metrics reporting the health, the internal pipeline steps, and so on, the one that we just described a few minutes ago. Those metrics then can be sent to any output plugin supporting metrics. Health. Health is a plugin to enable the health checks on the agents. So if you want to add health probe on the Fluentbit agents, make sure to enable this plugin. Then we have all the plugins related to exporter. So we have the Nginx exporter that will scrap metrics from the Nginx status page. And if using Nginx Plus, you can even interact with the API provided by Nginx Plus. The Node Exporter Metrics is a plugin based on the Prometheus Node Exporter to collect system metrics on the host like CPU, disk usage, network usage, and so on. Then we have the Prometheus Scrap Metric where we can precise the host, the port, the path of our Prometheus exporter where there are some metrics to collect. Fluentbit will scrap the metrics every X seconds. This is a settings that could be configured with the time interval parameter. StatsD is an input plugin that will enable Fluentbit to receive metrics using the StatsD protocol. Then we have the Windows exporter metrics that will, based on the Prometheus exporter, that will collect host metrics, network usage, memory from our Windows servers. Last, the most exciting news is the support of OpenTelemetry.
I think I just peed a little.
With the OpenTelemetry input plugin, Fluentbit will listen for OTLP HTTP data. By default, it will listen to the default port of OTLP HTTP, which is 4318. And it will automatically expose new endpoints on the agents to be able to receive traces with v1 traces, to receive metrics, so v1 metrics, and to receive logs with v1 logs. One important point is that if you are exporting traces or metrics or logs with the OTLP protocol in your SDK or on your collectors or whatever components, the data will be compressed using the JZip compression algorithm. Therefore, if you want to be able to see the data in Fluentbit, you will have to disable the compression, except there is an option where you can say that you want to see the raw data without modifying it and just forward it to the output plugins, raw_traces, where Fluentbit will only be a pass-through to your output plugins. For example, here is how you can disable from the collector standpoint the compression. The Fluent community has added new output plugins related to the support of metrics and traces. As expected, we'll of course have the Prometheus remote write to write directly in a Prometheus server, the Prometheus exporter where Fluentbit becomes a Prometheus exporter, the official OpenSearch output plugin, and of course, as expected, the OpenTelemetry output plugin to send metrics, logs, and traces. Since several releases, Fluentbit supports the stream processing tasks. Fluentbit, in top of collecting, processing, and filtering our logs, can also perform data analysis. Usually, data processing is something that we do once the data is stored in our Observability backend of our choice, using, for example, LogQL from Grafana or DQL, so in Dynatrace. It could happen that we want to run real-time analysis on the data to report KPI that we would like to use to alert or create SLI or SLA. The traditional data pipelines of Fluentbit will follow the following structure. So we start with an input where we collect the data, then we parse, then we filter, and then there's a step called storage before going to the router and to the various output plugins. Storage is not a step of our pipeline, but technically Fluentbit is storing locally the stream managed by Fluentbit. The storage by default is in memory, but it could also be configured as in a file system. The stream processor is acting as a side process that checks the records that has reached the storage layer. So in the case, if we use the stream processor, we'll have the input, the parser, the filter, the storage, and then the router and the various output, and the stream processor will basically be directly at the storage location. The stream processor will allow us to run stream tasks, where we can run a sort of SQL query against the Fluentbit streams. Those queries are named stream tasks. Fluentbit rely on the SQL language to query and create new streams out of our data. So here is the syntax. So create stream with the name of the stream. You can add some property names, and then you have a SQL statement at the end. So it will be combined, of course, with a select statement. So we can say, here is an example with create stream, hello, and then we can say we want to select all the logs from a specific tag, Apache. But this SQL language allows us to create aggregation functions like average, count, minimum, maximum, sum, and so on. So at the end, we can imagine to create a stream that will have the following stream tasks. So create stream, hello, and then here we can say select star, we select all the logs, and then we count the number of logs. We can use group by, for example, in this example, we group by URL. So here we're filtering also with only the methods equal posts, and the status is 200. We can also add properties to the stream, like the tag. So for example, here we can say we can create a new stream having the tag equal tests. If Fluentbit is able to manage traces, metrics similar to logs, we can ask ourselves, what is the difference with the OpenTelemetry Collector?
Round 1. Fight!
Well, for the moment, we cannot really compare both solutions simply because most of the filter plugins of Fluentbit are only designed for logs, which means that Fluentbit acts like a pass-through for metrics and traces. But we should expect to have soon filters that will also be able to add extra metadata to the collected traces and metrics. The main difference is the naming. In the collector, input plugins are named receivers. Filter plugins are named processors. And last, the output plugins are named exporters. The collector provides lots of various receivers, processors, and exporters to manipulate the data from each telemetry signals supported by the OpenTelemetry project. Meaning that I can receive traces from OpenTelemetry, zipkins, I can receive metrics from my Linux host or Windows or macOS server, logs from the systems, and then start processing it. The collector today provides lots of processors that help us to enrich, modify our telemetry data. There are specific processors that will add, similar to Fluentbit, the Kubernetes attributes to our data. There are also specific processors to adjust the sampling decisions of our traces to transform our logs or metrics and more. So today, the collector will obviously have more plugins allowing us to modify our metrics and traces. But this should change soon with all the work that the Fluent community is currently working on. One major difference, I would say, is mainly on how you design your pipeline. Currently, the collector doesn't have this notion of tag that allows us to route the data through specific filter or processors in our pipeline. The logic in the collector is a bit different. In fact, recently the collector community has introduced this notion of connectors that acts as receivers and exporters. With this feature, we can process a source and then send it to a connector. So here is the link to the connector README page in GitHub. The connector can be a receiver of another pipeline to enrich or adjust the data before sending it to the Observability backend of our choice. So the collector doesn't have the tag, but the connector feature can almost replace it. The collector also currently doesn't have the filter expect that can help us to make sure that the data is matching a specific format after having processing it. The design experience between the both products is clearly different. But from my perspective, this notion of tag is clearly helping me to create more complex pipelines and route the data to the right steps based on this notion of tag. The collector pipeline has also a great advantage. You can differentiate pipelines for each data type, so metrics, traces, logs, and other. So you're controlling what type of flow you want to apply for a specific type of data. The other exciting aspects that we briefly talked about with the updates of Fluentbit is the new way of designing our pipelines in Fluentbit using the YAML structure. So we would be closer to the design format of the collector by defining our pipelines and precising which input, filter, output we want to run from our data. if you're currently modifying your traces, metrics with the help of the collector, then it means that you would need to be patient before you switching to Fluentbit, because you will probably need extra filters to be applied on the metrics and traces. But what is actually great from my perspective is that we can actually reduce the number of workload in our cluster. And if I'm only using the collector as a gateway, like a pass-through, then I can also use Fluentbit to do the similar tasks. I will collect logs from my pods, I will receive the traces, the metrics, and then I will export it to the right Observability backend. In order to get more details about those updates provided by the version 2 of Fluentbit, I think it makes sense to call one of the maintainers of the FluentD and Fluentbit project, and also the founder of the company called Calyptia, providing an enterprise solution to manage your pipeline and your Fluent agents. And I'm referring to Eduardo Silva. Hi Eduardo, how are you?
Hi Henrik, very good, very good. Happy to join you again on this episode remotely. So yeah, really happy to share news or everything that you wanted to know or whatever I can share.
Since our discussion that we had at KubeCon Detroit, where you announced the support of metrics and traces, I really want to go deep dive into the version 2 of Fluentbit, because it's very exciting to hear the support of Fluentbit on other signals than logs. Since the last 2 weeks, I've been playing with Fluentbit, and I have tons of questions. So before we actually start the interview, could you introduce yourself to the community?
Sure, my name is Eduardo Silva, originally from Chile. I live in Costa Rica for the last 10 years and have been doing open source for the last 20 years in development. Like 7 years ago, I joined a company called Treasure Data, where FluentD was created. I created the Fluentbit project at that company. We both together donated the project to the CNCF, and that's where the big journey started with all this observability movement at the era when Kubernetes was created too.
What is the story behind Fluentbit? And why did you decide to create another component Fluentbit when FluentD was already out there on the market?
Yeah, actually I can do the very, very short story or go back to 20 years ago, because you might think that, this project was created 6-7 years ago, but the other day I was doing some kind of introspection, how I ended up here, right? And things started many years ago. In Chile, we used to run these national Linux conferences, right? All DevOps people, more than DevOps people who wanted to learn about Linux. So we shared how to configure bind, DNS. Everything was really obscure at that time, right? The graphical interface of Linux was not like a good thing like this is now. We are not in the year of Linux in the desktop, right? We know that. But years before was this time when you used to compile the kernel, get sources for everything, for GIMP, from Inkscape, or try to build everything from scratch. And somebody was presenting a new project called an embedded web server, right? Everybody was using Apache at that time. And we're talking about Apache version 1. And the concept was really good. A lightweight and performance solution as a web server. And they made it open source. And at the end of the presentation, they tell us, hey, if you want to contribute, please just raise your hand or talk to us after this presentation. Okay, I like this. Okay, so I approach this person and tell, I would like to contribute, I would like to learn. And he asked me, do you know C language? And I say, not yet, but I can learn. No, you cannot contribute. Really? But I think I can learn. No. Okay, good to know. So I decided, can I learn C? Can I not learn C? Okay, I'm going to build my own web server project. And I started a project called Monkey Web Server at that time. Actually, it was pretty much at the same time that Nginx was created. So I focused on creating a web server in C language to learn C, but also learn more about embedded Linux at that time. And I started running that project. I started creating this mechanism like Apache used to work like in a forking process model. Every time that you got a request, you create a process. It was very inefficient at that time. But we're talking 20 years ago, right? So I implemented that process. Then Apache moved to threading model. I implemented threading model. So we switched Monkey to threading model. Then Nginx was born too, and we were playing with this kind of event loop model, asynchronous I/O. And I moved Monkey to that new model plus threading, and actually I'm always measuring how how Monkey could do against Nginx. And actually we were right almost at the same level of performance. So in my mind, there was always this concept of, hey, this can be done better, this can be faster. But also, yeah, it's like I have a car, right? You can have a car that could be really, really fast. But the question that nobody asks is how much gas you need. And in software, it's the same. You can be really, really fast, but how much energy you need, how many processors, or how many machines, right? So I bring this concept in my mind with Monkey for many years, optimizing for performance, low memory, low CPU, but high throughput. And well, the time goes on. I was working at Oracle in support area, Oracle Linux. Then I jumped into Ksplice, and then I hit into Treasure Data 7 years ago. And they had this project called Fluentd. So we got this intention to solve the log management problem. How you solve the problem of moving different sources from different formats to different destinations without writing your own scripts for each single source. So Fluentd becomes like a good solution. It was written in Ruby. And at that time, we were thinking like, hey, I'm talking 6-7 years ago, right? Everybody was talking about, hey, IoT, billion devices will be connected nowadays, right? Pretty much you will be living in the future today. We are in the future, but not in the future that we envisioned at that time. If billion devices are connected to the internet, those devices will generate tons of data, same as servers. So the same problem that we got in Fluentd was solving for servers, for machines to collect data from different formats, different sources, we will have it for IoT. And IoT was referring in our context to embedded Linux. So my POC was, hey, let's write a new agent, right? And the story said, oh, why? We don't need a new one. Maybe we tried in Go at that time, not in C language. And yeah, Go was not mature enough for ARM devices. And embedded was ARM. And I say, okay, let me work on something. So I took Monkey, which I have all the architecture for threading, all the architecture for asynchronous I/O, and I took the main event loop as like a layer, and I built Fluentbit on top of it, right? So Monkey becomes like the main engine, right? For the event, I reuse many components of it. So writing something from scratch, it was not like that, right? It's something that started many years ago, with a whole mindset of performance, low memory consumption, low CPU consumption. And we were starting playing around with different small devices and talking to people, talking to companies, and we see some kind of traction, right? But in the embedded world, everybody has a different way to do things. There's no standards. Yeah, they will say there are standards, but they are not. They created one foundation, they changed the name, they changed the project. Yeah, it was not like a good fit for the project. And at the same time, Kubernetes was taking off, right? And Fluentd becomes like the de facto solution for Kubernetes, right? And actually, we got a lot of a comment that saying, hey, this is a solution written in Ruby. It doesn't match with the Kubernetes stack, which is all pure Golang at that time, right? But it solves the problem, right? So that's why companies started adopting Fluentd. But at some point, they said, hey, Fluentd is good, it's flexible, but might not scale in the future, right? It's a single process. It's a single process system, right? It's Ruby. And they started experimenting with Fluentbit. And people started asking, hey, can you write a plugin to collect data from logs? Can we connect to systemd? Can we connect to the Kubernetes API server and enrich the logs with that? And add, an Elasticsearch output plugin? And we say, okay, let's pivot to the cloud. Instead of embedded, we pivot the project to the cloud and started building all these plugins, going to conference, showcasing what we were doing, and we get really, really good feedback.
It's an amazing story. I didn't think that there was almost 20 years of history behind this project. In this episode, I talked about the support of metrics and traces, and I also took the time to look at the various features that I didn't have the chance to see when I produced my first episode about Fluentbit 1 year ago. I think that the community is adding lots of great valuable assets to make our job better and easier. I guess you already have lots of ideas in your backlog, so could you share some updates or roadmap related to Fluentbit?
Maybe I can also share a little story around why the new features and extended the scope of Fluent pretty quickly. It's like we got many users asking us to, hey, can you achieve XYZ besides logging? And most of them were referring to metrics, right? And at the moment was, no, you can do it with Prometheus Node Exporter, or you can do with XYZ tool, right? And they always push back and say, hey, you know what? I don't want to manage 2 agents or 3 agents. Can you integrate all of this in one agent? Because Fluentbit is very lightweight and it's very performant. And I don't think that it's different from what the other tool is doing, which is times heavier. And from a project perspective, we decided, hey, you know what? That makes sense. Actually, we got some initial conversations with the OpenTelemetry community, but also we found that the users has similar problems. Many agents, many telemetry data types, and when you deploy a new agent, it's not just deploy a new process or a new type of agents. It's also, it assumes that you need to understand how it works, how to maintain it over time, because this will go to production. So if people is running Fluentbit for a couple of years, it will be good just to use the same technology. And from a metrics perspective, we started implementing our native metrics solution that is compatible with Prometheus. We started the journey around Fluentbit 1.9 early last year, right? Where we can do Prometheus scraping, Prometheus remote write, Prometheus exporting. And yeah, it was really cool and people like it. Actually, we got the first big suggestion was, hey, can you replicate Prometheus Node Exporter inside Fluentbit? Yeah, why not? So it was pretty much copy-paste Prometheus Node Exporter inside Fluentbit. We have a really good relationship with Prometheus project. And they say, oh, that's cool. Yeah, I think that for most of the projects that collect and store data, they just care about to receive the data. They focus also on the collection piece, but most of the value is in, when you process data or you can process the data. So we replicate this functionality, and we got a ton of users that stopped using Prometheus Node Exporter and instant switch it to the Fluentbit plugin that does the same. Yeah, we create the same metrics, same description, same labels, everything. And most of this extension has been based on demand, right? If we see 10 people asking for the same thing, it means something. And some of them comes from big corporations that say, hey, I'm running 2,000 servers and we need this. So we just talk to the maintainers, to the developers, come up with a plan, and just go ahead and implement the stuff. As Fluentbit 2.0 that came out last year, we just shipped Golang support for Golang input plugins, support for Wasm plugins, so you can write your input plugins, for example, in Python, on Rust, and just connect it to Fluentbit. Because also the community was not just users, but a ton of developers. And they say, you know what, I don't want to have to learn C. My problem is very simple. I have a package in Rust. Can I integrate it with Fluentbit? So we ran a couple of POC, many companies were doing so, and we come up, hey, it's with Wasm, right? You will not achieve the same performance as writing a plugin in C, but it solves the problem, right? There's always a trade-off on any type of technology. Also, we made the input plugins run in a multi-threading mode. I don't know if you remember that I said at the beginning, everything was asynchronous in one process, right? So you have a one main event loop that kind of schedule every time that you're going to receive data from one place and send to the other. And we were using coroutines for that. So you have like a function. You just, for example, you create a TCP socket. You're going to connect to an endpoint. So we tell the ML loop, I'm going to connect, I'm going to suspend the execution of this function. Please let me know when the connection is ready. Because that job is done by the kernel. And then internally, the code suspended and then resume it. And it was a really good approach. But at some point now, people wanted to do a process 2x or 3x that they were processing the last year with the same agent. So, and all of them say, hey, I have plenty of CPU cores, what I'm using just one. And it makes sense. We extended last year to multi-threading in the output. So every output plugin that runs in a couple of threads. Every thread can handle multiple connections or multiple flashes, right? And for the input side, we come up with a strategy where input plugins can run in a separate thread, but without modifying the plugin source code. So we did everything from an engine architecture change, where every plugin can benefit. Yeah, when you have 100 plugins or more, right, you need to come up with solutions that apply for all the connectors that you have and get benefit right away. Also, we started implementing OpenTelemetry support in Fluentbit, and I know that this is one of the major questions, like why, right? And the thing is that, as I said with Prometheus, they say, oh, you know what, we're experimenting with OpenTelemetry, right? But the OpenTelemetry Collector is not as lightweight as Fluentbit to sit on the node. And I said, can I use Fluentbit? Oh yeah, why not? So we started creating the input telemetry input plugin, the output plugin, and with this, and we found that, hey, we don't support traces. Oh, let's build a layer for traces. Actually, in Fluentbit and in Fluentd too, we are very agnostic from the data type. So supporting logs, metrics, and traces becomes like an upper level layer, right? That benefits for the whole engine that does routing, buffering, retries, logic, all the complexity. So I think that for us, OpenTelemetry borns as a specification. So we just implement the OTLP protocol in the input, in the output, and we can support all these data types internally.
When are you expecting to deliver some filters on top of metrics and traces? Because I had two use cases in mind. First, I wanted to use the Kubernetes filter plugin to enrich my traces or metrics with the Kubernetes metadata. Second, I wanted to modify metrics that were not well designed. If a metric has too many labels or dimensions, it would be very expensive to store the data. So I wanted to drop labels out of those metrics to reduce the cost of those on the metric storage. Do you have those type of use case in mind? Has it been asked by the community?
Yeah, actually, from the company perspective that sponsor Fluentbit is our company Calyptia. That I think that's one of the majority of use cases. I would say that years ago the problem was focused on move the data from point A to point B in general, right, as an agent perspective. But now from the enterprise is, okay, what kind of processing I can do in the middle before sending the data to B, right? So the problem is moving from the left to the right. And this touches analytics, data reduction, the duplication, and a ton of things. In Fluentbit, we started supporting filtering many years ago with the goal to enrich data or drop data that matches certain pattern and you don't want it, or just modify the content. And one of the most useful filters that the community has found has been the Lua filter, which is the way to add scripting into the agent, right? And one of the advantage of this is like part of the story, right? Going back to the story again, we were in Europe like 4 years ago, 4 or 5 years ago, and it was more than 4 years, GDPR was starting, right? And one of the companies approached to us at the booth, and the Fluentbit booth, and they told me, you had a problem. What is the problem? Yeah, GDPR is coming, and in our logs, we have the credit card numbers because we are handling transactions. Oh, okay, and what is the problem? I know it's a security concern, but with GDPR, we need to bring some internal logic that says if this credit card from this place, we need to obfuscate the data in a certain way. Oh, so you cannot write a C plugin because it will be really expensive in terms of time and money. Yeah, exactly. And we come up with the idea, hey, what about if we do this like a scripting, with a scripting solution? Nginx support Lua. Why we cannot support Lua here? And that's how Lua filter bonds. So you can bring your own business logic when the data gets in. Yeah, you can do whatever you want because you get a Lua table, which is like a JSON map. And you say, oh, if I have this data, do this. Otherwise, change the timestamp, drop the record, or whatever you want. So Lua right now, getting back to your question, just exists for logs. And we're going to extend the scope for metrics and traces too. Actually, if you abstract, metrics and traces are just a different schema, but they tend to be the same type of data, right? Internally for us, it's the same thing. And also, we are launching now Fluentbit 2.1 around April 10. Actually, I'm wearing the new Fluentbit t-shirt. I don't know if I can share it. This is the Amsterdam version, right? You will get, yeah. So we just got it last week. So for every major release, we're going to have a new t-shirt. So that's really cool. And we're going to present first. One of the things that we had missing is like in logs, you have the content and usually place the metadata for logs inside the log. For example, Kubernetes, right? You get annotations, labels that is inside the log. But if you want to play with OpenTelemetry logs that is getting some kind of adoption, right? That data is not there because it's part of the record and not part of metadata. So we said, in Fluentbit, maybe we need to add this concept of metadata in general. So you have, and actually we have metadata. The timestamp is metadata for a record. It doesn't matter what it is, logs, metrics, traces, that is metadata. So we come up with a format that's going to extend that metadata piece without affecting the filters, without affecting anything in the engine, that we're going to support that. Other thing that people were asking is like about hot reload, because now there's a huge trend about fleet management, right? So the way to, remotely ingest a configuration or pull a configuration and hot reload the agent. So we're working on hot reload for Fluentbit 2.1 and all this filtering, as I said at the beginning, for metrics and potentially traces. We have some POCs, so we are trying to have everything ready for this version 2.1 in a couple of days.
There are several things that you mentioned that are very interesting. I know that the OpenTelemetry Collector has a couple of features related to traces, and especially on sampling, such as the tail and the head sampling. Are you planning to add similar features, or this is something completely out of scope?
I would say, I think that traces processing is really important. And if you ask me today, if you're doing traces, you should go with OpenTelemetry Collector, because that is something that comes from the open tracing world, right? Has been there for a couple of years, it's really stable. And I will not tell you, hey, just we're going to ship this in 2 weeks, right? No, just with the collector, because you need buffering, aggregation of the spans for tail sampling. It's more complex job. So right now that is a solution. Yeah, we have that in our list, but we are prioritizing the problems. So the solution for the problem that our user has. Our users want a high performant agent on the nodes, a high performant aggregator for logs and metrics, ideally traces, but we're not going to prioritize that because, people is using OpenTelemetry. And our vision is always integrate the ecosystem more than just go and be a drop-in replacement.
I want to get back to the topic of fleet management. So 1 year ago, I tried Calyptia, and I really liked the way of designing my Fluentbit pipeline to be able to push the updates to the Fluentbit agents. Currently, the OpenTelemetry project has worked on a protocol named OPAMP. Currently, there is a Java and Go client available for OPAMP. I was wondering if you were planning to utilize the OPAMP protocol to manage the Fluentbit updates and push any updates related to the pipelines.
No, the way that we are approaching this handling is not by using OpenTelemetry protocol. I think that when doing fleet management, protocol is just one piece of the puzzle, right? And there are other problems to solve. One of them is hot reload, right? I think that's the first one. The second one is how do you get the new configuration? And we can talk about hours between pull and push, right? But at the end of the day, who decides is the user. Based on their own restrictions in the network, most of people will not allow a push. They will allow a pull from the agent side. Right? They try not to expose ports, so just they connect when they want it. So, and from a company perspective, from Calyptia, in our product, which is called Calyptia Core, which is a pipeline solution, you can create telemetry pipelines for logs, metrics, and traces. We got this high demand for fleet management, right? We also, besides Fluentbit, we provide support for Fluentbit, but we have our long-term solution called Calyptia Fluentbit. And that is the agent that we are going to prepare to be managed by Calyptia Core, not just inside Kubernetes, but outside of Kubernetes too. So this will be our own implementation. We're not reinventing the wheel with a new protocol for our use case. We're going to do it pretty simple, but more information will be shared in a couple of weeks.
All right, so I think you answered to most of my questions. Thanks so much for your time, Eduardo. Thanks for sharing your insights and the history about the project.
Thank you, Henry, for the invitation, and happy to talk to you again.
That's it for today's episode related to Fluentbit version 2. It's very exciting to see Fluentbit supporting more than just logs, metrics and traces with this new version. As expected, we have new input plugins to receive metrics and traces, of course the OpenTelemetry input plugin, but also specific plugins to receive host metrics like the node exporter, the Windows metrics with the Windows exporters, and more. We also have output plugins to send metrics to Prometheus, and also, of course, the OpenTelemetry output plugins to be able to send the data to your Observability backend. As of now, as you understood, there are no filter plugin for metrics and traces. Like Eduardo explained, you can still script your own plugin using the Eula script, so the WASM, to be able to adjust the various metrics or traces. But be patient, you'll probably have soon a couple of new filter plugins allowing us to transform the various data that we are sending to Fluentbit. So if you're using currently the OpenTelemetry Collector to transform or adjust the metrics and traces, then you will have to wait to utilize the Fluentbit agent. If you use the OpenTelemetry Collector just like a pass-through, like a getaway, where you send the data, you don't modify anything, and you send it back to your backend, then Fluentbit could make a great job. This episode doesn't provide any tutorial, so if you're looking for the tutorial showing you how to send metrics and traces to Fluentbit and then push it to another Observability backend solution, then be patient. There will be another episode dedicated and providing the technical tutorials on Fluentbit. If you enjoyed today's content, don't forget to like and subscribe to the channel. So see you soon for another episode. Bye.